Hello everyone. Today I'm going to give you a video tutorial all about homogeneous differential equation. So, a homogeneous first order differential equation must have this following form: a function of m with x and y variables dx plus n, and also a function of x and y variables dy is equal to 0. So it must have this form. And next, to check if a differential equation is homogeneous, we let x to be equal to u times y, or y and y is equal to u times x. So that is we have a function of ux uy, since we let x into uy, and ux dx, and also a function of n of uy and ux dy. So that's it. So after substituting these things, or these following equations right here, so we will check. So in order for us to check is that we substitute, and then for further simplifications we might came up with this condition that in this function we have a u to the power of n, a function of m, and u to the n, a function of n, in which d has both n power. That makes it homogeneous. Otherwise, if these equations could this equal sign is not really can make it an equal sign, not just it has the same values, but what I mean is maybe this power right here are both the same or equal to n power. That means it has a homogeneous, or it is a homogeneous differential equation. If it is not, therefore it is not homogeneous, right? So that's it. That's the idea behind homogeneous differential equation. So for us to understand further, we might need some example. So this is also taken from the book Advanced Engineering Mathematics. In the page 32, this is an example, page 32, number 23. The question is to solve the equation dy over dx is equal to x plus 2y over 2x plus y. So we have to solve this equation. So we need some paper. Okay. So writing, we have this equation. This is 2 dy over dx is equal to x plus 2y over 2x plus y. So the first thing, we have to put this in this equation. So you have to multiply both sides. It makes it x plus 2y dx minus that, because we have to transpose it, to 2x plus y dy is equal to 0. So that's it. And then, since like it is a positive, for us to check again, we need a positive term. So since our n here is negative, so we might transpose it. So what happened to the equation is like this. negative 2x minus y dy. This is just to show you, for us to check, to show you, uh, by following the steps, to show you that it is homogeneous, or to check whether it is like an homogeneous differential equation. So I think this would be like this equation, right? So what we do next is to check, right, to check or to substitute. So to substitute the x to the by x to uy and y to ux. So what happened is that we have a function of uy and ux. So what happens is like this. So this is our m. We have to, and x is uy plus 2ux. Okay, then this is equal to like this, y plus 2 of x. Then our n, okay, our n is also uy and ux. And then negative 2 uy and negative ux, negative 2y minus x. Since it has only a power of 1, like the u, so therefore we can say that this is already a homogeneous differential equation. So to solve it, we may be needing one only substitution. Maybe x is equal to uy or y is equal to u times x. So what I have done, my calculations, so what we're gonna do is to substitute, or we let y is equal to u times x, okay, and then the derivative of y is equal to u dx plus x du. Okay, so by substituting to the original, to the equation, right? Okay, now by substituting this to this equation, so we have this x plus 2ux dx minus 2x plus ux u dx plus u dy, x du, or x plus x du is equal to 0. Okay, so by distributive property, or by distribution, you have this x times dx plus 2ux dx minus negative, okay, 2x times u, so 2ux dx minus 2x times x du, come to 2x squared du. Then negative ux times u dx equal to u squared x dx, and then negative ux times x du is equal to negative u x squared du is equal to 0. So what have you found out? We can cancel this thing and this, that, and so no other. So we combine the same terms. We combine this dx, this term dx, right? So we have x and x dx minus u squared x dx. That means we have this x minus u squared x dx, okay, and then negative 2x squared negative u, okay, so that thing, so that means since we put this negative here, so that means you have to do this as positive. So negative times 2x squared, that means 2x squared like this, and then plus ux squared du is equal to 0. However, we can also factor out x. So that means x 1 minus u squared dx minus x squared 2 plus u. Okay, 2 plus u du is equal to 0, and we can cancel 1 x here, and then we have this 1 minus u squared dx minus x 2 plus u du is equal to 0. So evaluation, what can you say about this equation? Aha! We can use the separable differential equation, right? So, for example, to further continue this, okay. So our last equation is like this. We don't have the okay. So this is our last equation. 1 minus u squared quantity dx minus x quantity 2 plus u du is equal to 0. So in this form we have to separate variables. We must multiply it by 1 minus u squared to cancel it out, and to cancel x from du. So that is for us to separate, so we might needing this factor. So, and then after multiplying it, so we have this equation. Okay, so since we separate the equations, the variables from x and u, so we need that means we needing another technique, and that technique is the separable differential equation, right? So from homogeneous we simplify and simplify, and then we came out to this separable differential equation, but in this form like this. So okay, so we integrate both sides, both terms like this to like this, we integrate like that, but we made it positive for us to manipulate more easier. Okay, so we make it positive, that means we factor out negative 1 here, and then that makes it positive, so like that. Okay, so to integrate it, we have this integration of dx over x, that is ln of x, and in this term, what can you say about it? What can you remember? How to integrate like this? Aha, bright idea. Now you remember it. We might needing the technique how it pronounces it was awkward. Technique of what? There you go. You saw it more clearly. It is the partial fraction. Now you remember it. Oh, you're really a genius. Okay, so we just let it for now, let it as I naught is equal to ln of c. ln of c, because we integrate at 0 for us to have to avoid loss of approximately. Okay, so we need to solve for I naught. We need the technique of partial fraction. Okay, so since this is our I naught, okay, our I naught is like in this form, u plus 2 over u squared minus 1 du. So by using partial fraction, we have this u plus 2 over u squared minus 1, which is, we can factor the denominator into like this, u minus 1 and u plus 1. Okay, so and then we, by partial fraction, this is the rule, we have this denominator u minus 1 plus u plus 1, let the numerator as a and b. Okay, so to solve for a and b, we multiply it by this denominator. So we have u plus 2 is equal to that's right, u plus 1, and then b is equal to u minus 1. Simplifying by term, you have a plus b. Excuse us. Next is 1, that means times a minus b. Okay, that is correct. Next then is that we have the equations a plus b is equal to, that means this u here, this is 1, so equal to 1. And the next equation is a minus b is equal to this term 2. Okay, so maybe we can use elimination, substitution, or the other one, or you can use your calculator. Then furthermore, you will have this following values for a and b. Since we have 2 equations and 2 unknowns, we can solve the problem, and that by solving it, it depends on you how to solve it. But there are many ways how to solve it. Just what I said: elimination, substitution, or you can easily use your calculator. So from that, we can get these following answers. Our a is equal to 3/2 and b is equal to negative 1/2. Therefore, our I naught is just equal to the integration of our a, which is 3/2 times 1 over u minus 1 du plus negative 1/2. This is 1 negative 1 to u plus 1 du. Okay. So this is simply as 3/2 of ln of u minus 1 minus 1/2 of ln u plus 1. Okay. So going back to this equation, right? Oh, where is it? Going back to this, where is it? There it is. Going back to this equation. Okay, going back to that equation. Back to the equation. Star. We say at the star. If we note this as star. Okay. Star. Okay. Going back to the equation star. So ln of x is equal to plus I naught, which is, this is our I naught, 3/2 of ln of u minus 1 minus 1/2 of ln of u plus 1 is equal to ln of c. So I'm gonna rewrite the equation. Okay, in the next paper. Okay. Minus 1/2 of ln of u plus 1 is equal to. Okay. So what we're gonna do is transpose the ln of c into the other side. First, we have the following equation that has an ln, both ln. So it is easy for us to manipulate the answer. Okay. So it becomes negative ln of c, which is equal to 0. Okay. So from here, wait a moment. Okay, from here. So by using the property of ln, okay, we have ln of So this becomes x plus ln of u minus 1 3/2 minus, okay, ln of u plus 1 to the 1/2. The negative to the negative, that becomes positive. So ln of c is equal to 0. Okay, next is we'll have to make it only one ln. Okay, so this is x times u minus 1 to the 3/2 over c times u plus 1 to the 1/2 is equal to 0. So applying the inverse ln, or the inverse function, or the inverse way to make it like that. Okay, that to make it for us to cancel out the ln, we apply a, so it becomes like this term already: u minus 1 to the 3/2 over c to u plus 1 to the 1/2 is equal to a to the 0, that is 1. Okay, so it's transpose x times u to the 1/2 to the 3/2 is equal to c times u plus 1 to the 1/2. Next, remember that we are using substitution, that our y is equal to ux. So we will make a way that our final equation, or our solution, is having only x and y variables. Okay, that means our equation contains only x and y variables. So our u is just equal to y over x. Okay, so returning to the equation, x times u is equal to y over x. So to make it a shortcut, we immediately having the denominator of x, and then since this is 1, so that means this is have to be x, since x over x equals to 1, right? So 3/2, and then c to the y, the same thing as this side over here. Okay, like that. So we can cancel out the x, right? So this, what happened is that 1 over x over 1/2, that means 1. This is 3/2 over here, so 3/2 minus 1 is equal to x to the power of 1/2 times y minus x is equal to c times okay, 1 over x to the 1/2 over times y plus x to the 1/2. So this term cancel out, and then what remain is this. This is 3/2, I forgot it. 3/2, and then y plus x to the 1/2. Okay, and then to simplify it more further, we have to multiply it to the power of 2. That means we have this to the power of 2. So y minus x to the 3/2 c to the power of 2. Or since this is a constant already, or this is just a constant, we just let it still c. C to the 2 just, or c to the power of 2 is just already a constant. What makes it a constant again? So what I am trying to say is that a constant times a constant is still be a constant, so that means you have to remain it as c. It means a constant or some variable constant. So this is y plus x. So this is our final answer. Okay, this is our final answer. Oh no, this is 3/2. This is 3/2. That means power 2 cancel, power 2 cancel. Oh, this is a final answer. Oh, okay, so we got it right. So thank you for listening.